Welcome back guys to our second class, which is class 2. In class 2 we are going to look at networking layers. Under networking layers we will cover introduction to OSI model, the OSI layers, OSI data types, protocols and devices that are applicable at every layer, and the TCP IP model. So OSI model. OSI is a full form of Open Systems Interconnection. This protocol or a method or a concept was created in 1984 by an organization called International Organization of Standardization, which is popularly known as ISO. So this is a method that shows how data moves over the network. The OSI model will help you to understand how data move at every layer and how the network works at those respective layers. So some advantages of this model include it makes network troubleshooting very easier, and another advantage is different networking products can work together in the network. Like a Cisco router can work with a Huawei switch in a network. Basically, the model has seven layers, which are physical, data link, network, transport, session, presentation and application. Data pass through the seven layers during communication. Data moves through the seven layers during communication. And the best way to master these layers, just say this one: please do not throw sausage pizza away. So please do not throw sausage pizza away. So that's the best way to master the seven layers. OSI layer. Under OSI layers, we look at every layer, understand how each layer functions, the devices that are used in such layers, and so on. So there are seven layers in OSI model. The first one is physical, data link, network, transport, session, presentation and application. I said earlier, the best way to remember this is please do not throw sausage pizza away. So let's start by application layer. Application layer provides an interface between the user and the internet, as shown here. The layer that provides this interface is called an application layer. For example, when an user wants to access the internet, they use an application such as Chrome, Mozilla, Gmail, Facebook, Twitter, etc. So the layer that will act as an interface between the user and the internet is called an application layer. The application layer provides services like sending mails, transferring files, web browsing, working on social media, and etc. You can name them. So just have to understand the functionality of this layer. Okay, let's move to the next topic. Presentation layer. Presentation layer is the second upper layer of OSI model. and it carries out the following tasks: encoding and decoding. Encoding is the way human readable text are transformed into binary formats that the computer can understand. Let's say you want to send hi Dan. The presentation layer will transform this data into zeros and ones so that the computer can understand the data. Then on the decoding side, this binary format will be transformed back to human readable text. As you can see, this one can happen during sending, this happen during receiving. I hope you understand that one. So the zeros and ones will be transformed back to hi Dan. So I hope you understand the difference between encoding and decoding. Another function is encryption and decryption. In encryption key algorithms are used to encrypt user's password or change user's password into a format that cannot be read or understood by third parties or unauthorized people. Like when your password is done at 2021, the encryption mechanism will transform this password into this text here. It includes numbers, characters, letters. Decryption uses decryption key algorithm to change. It uses decryption key algorithm to change the encrypted password, which was this, back to understandable format that human being can understand. So this password here, this encrypted password here, it is changed back to done at 2021. So I hope you understand the difference between encryption and decryption, compression and decompression. The third functionality of presentation layer. During sending data is compressed to reduce the size. Like when your data was 2 GB, it compressed to 1 GB while sending, at least to reduce the size. I hope you understand that one. So decompression happens on the receiver side to regain the original data size that was sent. So while in compression, you are reducing the size of data to send it, but while receiving it, data is decompressed back to its original size. Like 1 GB is decompressed back to the original size, which was 2 GB. So I hope you understand the three functionalities of presentation layer. Let's move forward. The third layer is called session layer. This layer creates a logical or a virtual path between the source and destination before any communication. Here are the three functionalities. It starts a session. Before sending or receiving any data, the session layer creates a logical path between the sender and the receiver before sending any data and receiving any data. I have mentioned that. So after starting the session layer will manage the session. It will take care and monitor the logical path created during data communication and also protects the logical path. Then the third functionality. When the sender and the receiver has done sending and receiving data, the session layer ends the session. The session layer closes the logical path when the data transfer is complete. So I hope you understand these three functionalities of session layer. The next, transport layer. In transport, I'm sorry, this one was for a session layer. It should not be there. The transport layer carries out the following tasks: segmentation and reassembling. Segmentation happens at the sender side to break the original data into segments. It happens at the sender side to break the original data into small pieces or segments before sending it. The data are sent as segments. For example, bring it, done, would be sent as segment bring, segment hit, segment done, as you can see. So it's being broken into pieces, and every piece is sent at a time. Every piece is sent at a time. At the reassembling side device, it collects these data pieces or segments, collects the data pieces or segment to form the original data, collects the segments back to form the original data. For example, when the data was sent as segments bring, segment hit, segment done, is put back to form bring it done. So understand that. I hope you understand the difference between reassembling and segmentation. And the second functionality of transport layer is flow control. In flow control, the transport layer manages the flow of data speed while sending and receiving data. It ensures that the transfer speed of both sending and receiving devices is matching. For example, device A is sending data to device B. So the transfer speed here must match the receiving speed at this point. Error control. While sending data, sometimes data gets lost. So the data lost during the transfer process is sent back by the sender. So the sender will be asked to send back the data or resend the data in case there is any data loss under error control. So I hope you understand the three functionalities of transport layer. Let's go down to another layer. Network layer. Mostly the devices that are applicable here are layer 3 routers and layer 3 switches. Layer 3 switches are also called multi-layer switches. They carry both routing and switching technologies. So I hope you understand that. And at network layer, the following are the three functionalities. The first one is routing. Routing is a process through which a router uses to connect one network to another or connect different networks. Routing is used to connect one network to another or different network, multiple networks. Assigning IP address. In the network layer, the data is assigned the source and destination IP address while being transferred, such that the data has both the source and destination IP address, source and destination IP address while sending it. I hope you understand that. Selecting best path. Wherever there is multiple paths to the destination, the router will choose the best path to route or send data. For example, we have 6 routers here, and they are connected like this. They are connected like this. They are connected like this. Like this. So this router, while communicating, will select the best path. While routing data, the router will choose a path, whether it's this one, and this one, and this one. It will choose the best path to send data. It will not send data through the path. That will create a loop, what is called loop. It will choose the best path and route the data. So I hope you understand the 3 functionalities of network layer. Let's move down to the data link layer. Data link layer are carried out by, in data link layer, the devices that are applicable here are layer 2 switches, also bridge, you can name them, but the most applicable one is layer 2 switches. So in the data link layer, you have the following functionality. Framing is just a way of inserting a header at the start of the data and the trailer at the end of the data. The header and the trailer contains information which helps the data to reach its destination. For example, so this one is data, this one is header, and this one is trailer. So the trailer is inserted at the end of the data, header is inserted at the beginning of the data, and is being sent as a frame. Adding and deleting MAC address. While sending data, the destination and source MAC addresses are attached to the data. That's called adding. While sending data, destination and MAC addresses, destination and source MAC addresses are added to the data while sending. Then, when the data is received, once the data is received, these destination MAC addresses or source MAC addresses are removed. So you understand this one, adding and deleting. Flow control. As explained in the transport layer, flow control manages this transfer speed between the 2 devices. It makes sure that the transfer and the receiving speed, the sending and the receiving speed is the same between the 2 devices. And the error control, whenever there is a loss in data, the sender resends the data, as just explained in the transport layer. So you have to understand these 4 functionalities at data link layer. So let's check on them. So our very last layer under the OSI model is the physical layer. This is where the interaction with the hardware devices or physical components take place. Interaction between hardware devices and physical components are taking place. Hardware devices or components includes router, switches, hub, computer, you can name them. But physical components include cables, ports, connectors, as you can name them. Then at this layer, it's where the data is converted into various forms, as you can see. And when you are using copper cable and twisted copper cable, the data is first converted to binary, then is converted to electrical signal before sending. But when you are using fiber optics, the data is converted into binary, then to light, then sent. But when you are using wireless connection, the data is converted into binary, then into waves, radio waves. So for example, describe how data moves using copper cable. Untwisted pair, untwisted pair in physical layer. This is how to give a very brief and direct to point explanation. First, the data is changed to binary, is transformed into binary or converted into binary. Then the binary is transformed to electrical signals and move through the wire, the cable, the wires. So I hope you understand the seven layers of OSI model. Okay, in our next in the next topic, we're going to look at OSI data types and protocols. We have 7 layers as discussed earlier. So we are going to look at the devices that are applicable at every layer, the protocols, the data types. Let's start by the physical layer, the very layer at the bottom. Under physical layer, we have devices like hub, we have modem, we have cables, we have network interface cards. We have connector applicable under physical layer includes Bluetooth, DSL, Ethernet, etc. The data type here is bits. Yeah. So in the data link layer we have bridge, switch. Under network layer we have router, layer 3, switch. But from transport layer down to application layer, these are software layers. We only use application, we don't use any device here, we only use applications. So these are hardware layer, but this one are software layers. So you can see the several protocols that are used, like this one. The data types under layer 2 or data link layer is frames. The data type under network layer or layer 3 is packets. Under transport we have segments. Then from session to presentation we have data. You can see at the protocols. Yeah, you can look at them and understand how they work for UI examination purposes. Let's move on to the next topic, the TCP IP model. There are 2 categories of networking models. One is OSI model and the other one is TCP IP model. They basically work the same. So under TCP model, the method shows how data moves over the internet, just like OSI, but it was developed in 1978. We only have 4 layers here, which are application, transport, internet, access. In OSI we have 7 layers, but in TCP IP we have 4 layers. Okay, so let us move to understand the difference between OSI and TCP IP model. Comparison with OSI model. OSI model has 7 layers while TCP has 4 layers. They both function the same. So let's compare this diagram. The diagram shows how the following layers work. So the top three layers, the three layers of OSI model function the same as the first layer of TCP model. Then the transport layer of OSI model will function the same as the transport layer of TCP model. The network layer of OSI model will function the same as the internet layer of TCP IP model. Then the data link layer and the physical layer of OSI model function the same as the network access layer of TCP IP model. So, and I hope you understand the various types of the various layers of OSI model and TCP IP model and how they function, and various devices that are found at every layer, protocols and data type. Okay, so let's move to the next topic. Oh, that's the end of today's class. See you in the next class. Bye.